It's recording. All right. So last time, what I did post was, well, we also went through a lot of examples, and I basically went through the imperial system, which has different units, for length, mass, and length, weight, and I think they call it capacity, which is basically liquid volume. How much liquid an object can hold. Here, what I'm going to consider now is the metric system. So that's what I'm going to consider now. And I actually saw this on a TED video. I probably should have shared it, but I guess it's okay if I didn't. But basically, the imperial system, which is what the United States uses, only 3 countries along with the United States, use the imperial system. Almost all of the rest of the world uses the metric system. Now, why do we still stick with the imperial system? Honestly, I don't know. I guess maybe because we refuse to change. I don't know. But this is actually, but what the rest of the world uses basically, except for us and 2 other countries, is the metric system. So that's what I want to start going through today. And again, I sent out the notes through email. They're posted as well. Okay. So basically, in the metric system, there's a lot of different units that are used for length, mass, and volume. And for length, the main thing is going to be based on a meter. And I was going to say, okay, and other units can be formed by adding the right prefix. You'll see like kilometer, millimeter, centimeter, stuff like that. And then for mass, it's the same idea. Basically, for mass, the only difference is it's going to be gram. There is actually a formal definition of gram. It's not quite the same as weight, because weight actually depends on force of gravity. If you go to the moon or a different planet besides Earth, odds are your weight is going to be different because the force of gravity is going to be different. Mass, however, is not going to be different. However, since we're staying on Earth, we can think of mass as weight, but the units people use are gram. And again, there is a formal definition in the book. And again, we get different units by changing the prefix. You'll see kilogram, centigram, milligram, things like that. And for volume, same idea, except here we'll use liter. So for volume, we'll use liter. Okay, so now here's actually the prefixes. And you'll actually see that the metric system is actually very nice. As you can see here, the prefixes are based on powers of 10. And you'll see when we actually convert between different units, use, for meter, for liter, for meter, for length, with different prefixes for meter. And for liters also different prefixes. You'll see that when you change it, it's just based on powers of 10. So it's actually very nice. Now, if I remember correctly, I think in middle school or even high school when they teach this, they don't give you all the prefixes. You have to remember them. But in my class, at least here, since everything is open book, you're not going to have to remember them. There is a way you could remember it, though. And this is actually what I have here. It's King Henry's drunken uncle drinks chocolate milk. If you want to use that to memorize it, to memorize the prefixes, that's your choice. But again, since everything is open book, you don't have to memorize it. Because again, the notes are going to be the completed notes will be posted. And the textbook you have as well. Okay, so now with that said, let's actually go on to some examples with conversion. So here what we're actually going to do is see how to convert from one unit to another in the metric system. So in other words, here we're going to wonder, okay, how 1 meter is how many milliliters? And the way you can actually come up with that is by moving a decimal point. you can actually complete this by moving a decimal point. Notice here that meter, which is at your base unit, which is basically in the middle, right? Millimeter, right? Milli, okay, that's the prefix here. That's 3 units to the right. 1, 2, 3. And so basically, the way you accomplish that is you can move the decimal 3 spaces to the right, adding zeros as placeholders. So for 1 meter to millimeters, we're going to move 3 spaces to the right. So I'm going to draw it out. So this is a 1, as you can see, right? So we have the decimal right after it. We're going to move it 1 space. We get a 0, okay? We're going to move another space because, again, it's 3 spaces to the right. So that's another 0. And we move a 3rd space to the right, like so. So in other words, we're going to get 1,000 millimeters. I know up here it says 1,000 times smaller, but again, really it's just moving a decimal point. That's what it boils down to. And in fact, that's what we get. 1 meter is 1,000 millimeters. So it boils down to moving a decimal point to the right. And that's what's really convenient about the metric system, is that with these prefixes, you're basically changing by a power of 10. Okay, so that's one example. So what I want to do now is move on to another one. So in this one, we want to know 1 meter is how many centimeters. And you probably know the answer already, but let's go through it just to illustrate how you would solve something like this. So we start at 1 meter, right? Because we're given 1 meter. And for centimeter, right? That's 1, 2 units to the right. Okay, I don't want to go too fast. So I'll slow down a bit. So we want to go 2 units to the right, right? That's 1, 2. And it's just like the previous example, except here we go 2 spaces to the right. So we have 1, right? As you can see, we have our 1. And now we go 2 spaces, okay. 1 space. And remember, we use 0 as a placeholder. And now we go another space to the right. We get 2 zeros. In other words, we get 100, right? We move the decimal 2 spaces to the right. So we get 100. So 1 meter is 100 centimeters. You'll also see later on when we move the decimal to the left, it's the same. When we we will later on move the decimal point to the left. I think the next example actually does that. And it's really the same idea. Use 0 as placeholders. So we have these 2 examples. Now here we have 1 meter is how many kilometers. So this is what we want to know now. 1 meter is how many kilometers. Okay, so again, kilometers, we start at 1 meter, just like before, okay? We're going to go 1, 2, 3 spaces to the left. Okay, again, we start at 1 meter. We're going to go 1, 2, 3 spaces to the left. All right, let's draw that. That is, let's do this. So we have our 1 here, okay? There we go. So we go 3 spaces. So we have 1, right? There's no 0 here because we don't have an empty, we don't need a placeholder yet. 2, as you can see. And we have 3. Okay. So what do we get? We get 0.001. 0.001. In other words, we have this, which is the same, right? Here, let me just switch to laser, which is the same as 1/1000 of a kilometer, right? Because this is the tens place, this is the hundreds, this is the thousands. So this is the same as 1/1000. Okay, so that's not so bad. So we have this so far. All right, let me just pause this. Let me keep that. Let me just pause the recording.